Good day. We are looking at hydrolysis, and this is a section of a textbook I found to show you. Your hydrolysis notes will be very thorough, but there are a few things that I want to highlight as we go through here. And of course, if you don't find my notes totally clear, you can read this section and get a handle on it. So hydrolysis, we're talking about a reaction of a compound with water, and it's either going to produce an acidic or basic or a neutral solution. The example is showing NH4 plus reacting with water, hydrolyzing the water, and it forms NH3 and H3O plus. So NH4 plus is acting as an acid. And we can tell that empirically by looking at using pH indicator paper. And there are all kinds of fun calculations with it. We've gone over this, how you determine if a salt is going to hydrolyze or not in this flow chart. We will have looked at that already. But what I want to highlight here are anhydrides. An anhydride means a compound that is yet to have water added to it. So SO3, when it reacts with water, it is an acidic anhydride because in this case it made H2SO4. If I did the same thing with SO2, it would make H2SO3. So it's formed an acid, that's why it's an acidic anhydride. And non-metal oxides, tend to be acidic. Now here we have examples of basic anhydrides. So here we have sodium oxide, and when we add water to it, we get 2 formula units of sodium hydroxide, which we know are a strong base. And we could do the same thing down here with calcium hydroxide. Well, actually it'd be calcium oxide plus water going the other way makes our calcium hydroxide the base. So this is trying to show you how we form anhydrides, or the anhydrate, forms acid or bases. And this is the reverse, how we can go from the acid or base to form our anhydride by removing water. So here are the periodic tendencies. So on the left, things are basic. And so you say to yourself, basic, alkali metals, alkaline earth metals. In the middle, things can be amphiprotic. Sometimes they're acidic or basic, depending on conditions. And over on the right with the nonmetals, they tend to be acidic. And yes, you should know the series of equations that can yield acid rain. And you should also know the sources. Where do we get acid rain? And so we can see that in some cases we get it from automobile exhaust and whatnot, things like nitrous oxide, so we talked about earlier in the reaction kinetics section when we talked about a catalytic converter, and also other cases where we might get it from the burning of coal or materials like that. So you should know how these different materials can react with water, combine with water in the atmosphere to produce acid rain. So that's totally fair game when we get around to a test.